Hello, everyone. I wanted to just go through one of the problems for homework tonight. I thought it would just be helpful. We talked about this a little bit in class yesterday, but I wanted to go over a little bit. First of all, using the trapezoidal rule, we know that this is our delta x. It's the height of the trapezoid. Delta x is 0.3. Here it's 1.4, and here it's 1.1. And then these are your y values at the ends of, or the sides of the trapezoid. And so you get 40.75. Now, this is actually for part B, okay? And then this is the beginning of part C. So what I did with part C is I graphed the velocity, and then I put a horizontal line to make sure that I knew that where it was greater than or equal to 60. And you can see how that velocity comes up here. It crosses at 60, and then it crosses again at 60. So I found these two x values, all right? And the x values of the graph correspond to the times. Okay, so then I integrated the velocity function from this left endpoint to this right endpoint, and I got 106 meters. Then for part D, they ask us to figure out how far apart these two particles are. So I first figured out what is the x coordinate, okay, the position for Q at 2.8. Now we are told that it starts off at -90, and then the change in position will be the integral from 0 to 2.8. And so when you take this integral and add it to -90, you get 45.93 and so forth. But then we still have to find out what is the position of point P. Now point P, a particle P, is the position is 40.75, and that we got using the trapezoidal rule in part B. So if we know the position of point Q and we know the position of point P, then we can just subtract those two to figure out how far apart they are.